These are our states of matter notes, and so we're going to be talking about solids, liquids, and gases on a molecular level, on a particle level. And so you're probably familiar with a solid, right? So this is a rock, it's a solid. And liquids, we know what those are. And then gases, just a reminder, gases are things like air, carbon dioxide. If you have steam going on a pot and there's water and there's steam, that would be gases. And so what is happening on a molecular level, so first let's just start with solids, and I'm going to draw a box here. Actually, draw a box for all three, because we're going to show kind of how the particles are moving and what the particles are doing in each of the three different states. Okay, so starting with solids, we have particles. That's what these little dots are, these little circles. And you can see that there's kind of like a formation. They're packed together. And they might move very slightly. So we'll talk about that in a minute. Okay, so packed, move a little bit, if at all. Now, what's going to happen, and you can draw this on the side of your paper if you have this with you, is this is as we increase temperature. Okay, so that's how you can interpret this. So as we're moving down, we're turning up the temperature, we're increasing the temperature. And what that does is when there's more temperature, it excites the molecules, the particles in that substance. Okay? I should have kept these a little lower. So here, they are closer together. And just like if you had a glass of water, how the water doesn't float, right? But it also isn't totally still like an ice cube. It's moving, but not like a whole lot. And so here we have more space, more movement, right? And then as you turn up the temperature even more, now the particles are really going. And there's more space between them. Okay? And so that is how you can visualize what the particles are doing. And the analogy I gave the students in class was, imagine you have an ice cube, right? That ice cube does not jiggle in your hand, it doesn't move, it's solid. Those particles are solid, they're not moving. But as you turn up the temperature, it's going to melt, and now the particles can move, but they're not going to like float away until it gets too hot, and then we have steam, and then the particles are flying up, into the atmosphere. Okay, so we're going to do one of these at a time. So we're starting with solids. So if you just want to write solid here, just to help you remember these are solids. So solids, particles are packed. Very little to no movement of particles. Solids have a definite shape, right? The shape isn't changing. It is what it is for the time being, and it has definite volume, right? It takes up a set amount of space. So this rock has a certain volume. It's not changing. Okay? So that's what we need for solids. Now, liquids, so I'll write that here just so we remember what we're talking about. Liquids have some movement of particles. Let's see what I do. So particles are loosely packed. They slide around. That says around. They also have definite volume. And some of the students are like, wait, they have definite volume. Yes, if you have a beaker of water, you know the volume of that water or that liquid. It has a volume. that you can measure, but it has no definite shape, right? So if I have a cylindrical beaker and then I put it into a square cup or something, the shape has changed, but the volume is the same. So that's what we mean by no definite shape and definite volume. And then finally, so we keep adding temperature, we're adding heat, we have our gases, right? And so our gases vary a lot of movement. I don't know why I said very. So very spread out. There we go. Particles. Lots of movement. And lots of space between the particles. No definite shape. And no definite volume. Right? So it's whatever the container is that you have it in, that's how much it is. Okay? And so those are the notes that we have for solids, liquids, and gases.